Hello everyone. In this nugget, we will talk about the Docker architecture. We know that the Docker is a host server and it can be virtual or physical on which the Docker is installed. Docker Engine is the underlying implementation of containerization technology. It supports the end-to-end workflows which are required for building, shipping, and running container-based applications. Docker Engine is a client-server application with three main components. So as you see in the diagram, first is Docker daemon. It is the persistent server process running on the Docker host. It does the work of building and running containers. So here is the Docker daemon in the core of this Docker Engine. The second one is a REST API based wrapper to communicate with the Docker daemon and provide instructions to it. So here, as you can see, is the REST API wrapper over the Docker daemon process. Third component is Docker command line interface based client to interact with the Docker daemon. Here is the Docker command line interface in this diagram. So whenever the client wants to communicate with the Docker daemon, it uses the REST API based wrapper to establish the connection. Now Docker uses different binaries for the daemon and client. Docker D or Dockered command is used to run the daemon, and Docker command is the client command. Okay, so here you see. So this is very important to understand and remember. At this point, it is good to understand that the daemon creates and manages Docker objects such as images, containers, networks, and volumes, etc. We will cover these objects in greater detail in the later modules. Now this slide provides an introduction to the various Docker objects. Docker images are the basis of containers. They are an executable package which includes everything needed to run an application, that is the code and the dependencies. Container is a running instance of an image. If we put it in an analogy of, say, object-oriented programming language, then image is the class and the container is its object. Object is the runtime instance of the class. Now how does a running instance connects to external world is governed through the network configuration on the container. It creates and manages container network namespaces and related resources. Volumes are designed to persist data which is generated and used by a container. However, the volumes are independent of the container's life cycle. What does it mean? Data isn't lost even if the container gets deleted or recreated. Registry is a hosted service containing images. Registry could either be a private or a public. Default registry on the Docker installation is configured to be as a Docker hub. We call it as a Docker hub. Finally, the service. Service defines how we want to run the application containers in a swarm cluster. The service defines a desired state, which basically means how many containers are required to be running for that service. So how many containers are basically working behind the curtains to bring that service up or make that service run. Let's get to the next slide. Now this slide provides a diagrammatic representation of the major activities performed by the Docker daemon. Here is the Docker daemon, as you can see here, which is running on the Docker host. Docker client performs interactions with the Docker daemon. The control commands can either be passed manually through the Docker client, or they come directly from the orchestration engine, as you see here. As we know, for running containers, you can either build images locally or pull them from the Docker registry. Okay, as you can see in the diagram, there's a Docker registry. One of the primary responsibilities of the daemon is to build images. Images, once built, are stored locally in the Docker host. In the diagram, I have taken images of Nginx and MongoDB and Debian, which are available locally on the Docker host. Once the images are built successfully, they can be pushed to the Docker registry. You have to push them to the Docker registry. Docker daemon can also pull published images from the Docker registry. The registry works like a store and you only pull the specific versions of the image that you require for your Dockers or whatever. Once the images are available locally, the Docker daemon runs the containers from those. Also, the containers run in the same Docker host as the Docker daemon. Here, we will quickly have a short practical demo of the above concept. I have an instance running in the Google Cloud environment which already has a Docker installed on it. So let's go there and connect to this using our putty. So let's connect to this particular instance. At putty, I'll put the host name of this instance, provide the authentication, give the path of the ppk file, and here we go. We will log in. We'll log in with this name. And temporarily, for the time being, we'll have the super user rights on this particular one for this particular session by, so let's say sudo su. Now, first, let's see a help on dockerd. So if you want to check the help on dockerd help, it will list you, and I will more it so that we can see page by page. And it will list all the different options that we have available for it. So you can change the server process itself using the different options here, like running in the debug mode, and or what's that option, or enable the insecure registry communication, and all of these different options you have available regarding the dockerd. Next, docker command is to handle operations of the Docker host. Right, so if you want to control the or manage the images, containers, etc. So if you see here on this command help, you have different options for managing the different components that we have seen on the previous slide. So we can have the options for managing the containers, images, and the networks, etc. Let me see if we have any images on this particular host. So that I can do using the docker image ls. So by default, I don't have any images available on this particular host, so I can either build a new one or just pull it from the default registry, which is the Docker Hub. Now let's pull an image of Nginx, which is HTTP server and reverse proxy. So I would say docker pull Nginx. That will, now here I'm not mentioning any particular version, it will pull the latest version of this particular image. So let's do that. So once the image is pulled, it is listed in the locally available images. So let's have a look at whether we have any image right now. So there you see the Nginx image available now on this particular host. Let's now see the different containers that we have running on this particular host. So for that, we will say docker ps. Right now I don't have any container running on this particular host, so let's run a container using the image that we have just pulled from the repository. So for that, I will run a container. So we'll say docker run. I will provide the name for this particular container. You can give it anything, so I'll just give Nginx test2, and I'm creating this container using the image I have just pulled, Nginx. Okay, so that will run my container out here. Now let's go ahead and check the containers once again using the docker ps command. So now if I say docker ps, it will list me all the different containers that I have. So there we have our Nginx test2 container that we are running. You can try out the different basic commands that we have around our dockers and images and containers. Hello everyone. In the previous nuggets, we saw that the Docker uses libcontainer as the interface to Linux kernel facilities. These facilities are required to run containers on the Docker host. Let's have a deeper look at them now. First of these facilities is namespace. Namespaces provide a layer of isolation to a container, and each container runs in its separate namespace. Processes in a namespace can only interact with resources or processes that are part of the same namespace in which they are running. So it basically limits the view of container. Docker engine uses the following namespaces, as we will see now. PID of the process isolation, network namespace, inter-process communication namespace, MNT namespace for the file system and mount points, UTS name for setting a separate copy of the host name. Now next is control groups, also known as C groups. Docker engines use C groups to share the available hardware resources to the containers running on that particular host. It is also used to enforce limits and constraints on the resources, the usage of the resources. It primarily limits how much a container can use. For example, you can limit the memory available to a specific container. It is applicable to memory, CPU, disk, I/O, and network. Now last is union file system, and this can be called as union FS also. These are layered file systems, which makes them very lightweight and fast. You can also refer to them as stackable unified file systems. It allows these files and directories to be transparently overlaid, forming a single logical file system. During build time, multiple layers of softwares are stacked to get the desired applications with their dependencies. Similarly, during the image pull from the registry, only the layers which have changed are downloaded. I mean, they are incremental kind of. Docker engine can be multiple union FS variants, including AUFS, BTRFS, VFS, and device mappers.